And so the first thing is the PDP and MarkLogic and Semaphore especially are really all about handling hard data problems. So if you just have a relational thing or a simple document thing, you can go to Oracle, you can go to MongoDB and get a decent answer. And there, we can do it, but we don't really offer the same kind of benefit that you get when the problems become really hard. So most of what you see people using us for, like we became really famous because healthcare.gov is on us. They had to combine thousands of different views of what an insurance policy was. Oracle was going to fail. They couldn't model it. So in desperation, they came to us. We had it up and running in less than a year. That's the kind of thing where we really excel. And we're going to talk about some of those. So these are the kind of questions. Are your users frustrated because they can't get access to the data they need because it's too hard? Do you have all different kinds of data, that you have relational data and document data, you have semantic triples, and you need to use them all together in one piece? Then that's where we really shine, especially MarkLogic. And is your data spread out all over the place so your users can't get at it when they need it? That's something we're really good at. So those are the kind of things that if you're having that sort of issue, you should definitely come to us and make it work. And so this is a more summary. Another piece of it is security. A lot of the data technologies out there are not nearly as secure as they need to be, especially in the world of Gen AI. Vector databases and things really have no built-in concept of security. You give them the data and they will happily share it with anyone who asks, which if you have billions of dollars of proprietary research information that your competitors can save by not doing it and just reading what you did, that'd be very nice for them, not for you. If you have sensitive customer data that you're just leaking out to anyone who asks, you'll be on the front page of the New York Times in ways that you really don't want to be on the front page of the New York Times. And also the rate of change. So we're going to, especially on the Gen AI, I'm going to talk a little bit about that. The world's changing all the time. You want to keep up with it. And our platform is really designed to change and move quickly. So let's talk about some of the technology that we have. And a lot of our users don't really know. So as I was discussing, the use case that we shine the most at, you have PDF files, you have your Excel, your relational data, you have your documents, and for some reason this slide is missing the triples data, but you take all of those things and you dump them into one place, and then you get this integrated view. And so this doesn't look like much, but our competitors don't work this way. Our competitor, if you go to CosmoDB, you say, they can support all these different kinds of data, but you go and say, this is my triples database. When the first time you go there, you have to tell it, this is a document database, this is a relational database, this is a triples database. And you say, that's what this is, and from then on, that instance of the database can only be used for that. So you put your triples data into your triples store, your documents, your relational database, and the problem becomes when you want a single pane that has all of that there, you have to figure out how to combine those and make them work. So the difference with MarkLogic, both as a company and as a product, is we think of all of these as being one thing. Everything goes into what you, even in a relational database, you'll have a sales table and a customer table. With us, it all gets dumped into one place. The GPS data gets dumped into one place. The triples are all there. And then as a company and a product, we're focused on making that big pile of stuff easily accessible, easily usable. And so it's a hard problem, and we don't make it easy, but we make it as easy as possible. So we're really focused on taking all of your different kinds of data so that this graph here includes the GPS data, it includes and that the other one at the bottom, it's actually ranking risk by taking it's householding, so that there's a triples model of this person is married to this person is a child of this person. So now you can do your risk analysis against families instead of individuals by combining your relational data with your triples data and then just projecting it and the key thing is this is a snapshot of Tableau. So the users of this system I've been on many, many sales calls where I've described all the benefits of ontologies, and then the users say, what's a triple? Never seen one. Where do they come from? And that becomes less and less as time happens. And this is at big banks, top 3 banks, they're telling me this. And so with us, the end users are seeing that. They're seeing a SQL view of the data. They go to our ODBC driver, they connect to it, and this down here is combining ontologies and semantic and relational data together. And on the top, it's combining all the GPS and everything else. So you can take all this complex stuff and make it available to your user in a really easy way. So this is really the core MarkLogic use case. So, and we have a lot of others, but if you have anything like this where I've gone to a lot, I focus on financial services. I've been to a lot of big banks. Everyone has dashboards. Everyone is unhappy with their dashboards because they're missing stuff. And so we're the ones who provide the technology to really make it so you're not missing stuff. And then the second big benefit you get, so this is from a bond. We had a system at one of the top 3 banks, and they were based on us, a search engine, and they were complaining that their customers would ask questions and they were only getting 1/4 of the answers they should have gotten because the people using it were the same people creating it and they knew their data inside and out. And the problem was that someone types the word bond, and the people who create the data don't think about the data the same way as the people who are querying the data. And so what happens is fixed income is another word for bond. A muni is a kind of bond. And so by combining an ontology of the financial products, and at the bottom, high yield, junk, high risk are all the same thing. And so users come in and say bond and high yield, and they're missing everything that's been indexed as junk, everything that's been indexed as muni. And they were complaining that their analysis was they would only get 1/4 of the answers they should be getting. And so by building fairly simple ontologies, and we're going to get a lot more into that later on, they were able to hugely expand it so that the people complaining about this were complaining that the document creators, they'd insert the documents and no one was looking at them, even though they could see questions were being asked where they should have been looking at them. And so they could get these people off of their back, make it so they weren't getting the complaints from the end users from the content creators that no one was looking at their stuff, from the users that they couldn't find stuff. And from a fairly simple effort of building these ontologies, making it work, they were able to make it so that their customers actually got the data they needed. And so this is another core. So combining all the different data types, making your data platform intelligent and able to understand your questions and expand them so that when you ask your question your way, we can make it so the question gets asked in a way that the content creators were thinking about it and getting the answers. And then we also have, this is part of our Semaphore product, we have the ability to create those ontologies, and that includes identifying index. I've been getting a lot of calls recently about identifying models, entity identification, and so there's problems where you have one company owns a lot of other companies, they have different tax IDs, they have different names, they have different addresses, but firms need to know these are all the same companies. So like Moody's spoke here yesterday, and Moody's has this issue that, okay, Boeing has all these warehouses someplace, or, and they don't say the word Boeing on them, so who knows? And so the ability to do this model entity identification, both at an ontology level for concepts and also at the firm level, is something that we're very good at doing. And that's partly through Semaphore, that's also with our smart mastering technology. And so we can help you de-ambiguate all the firms to figure out exactly who's, what's. We can help you classify the data, which becomes really important in the Gen AI world, because if you've been paying attention on a lot of these sessions, people have to chunk the data. And so you might have a 100 megabyte document or a 10K document, a 100K document, and you split it into 1K pieces, and that's what you feed the LLM. And so in those kind of situations, you need to understand what each chunk is indexed for, what it's about, because you want to be able to send the appropriate thing. And we offer really world-class abilities where you know what the document as a whole is, you know what this piece is focused on, and we can get it to you. We can extract facts from your documents, so that in that first slide I showed you, there was a credit report PDF, And then one of the tables, one of the dashboards inside of it was what the titles of the people were. And that's because we were extracting what the positions of the people were from the different documents. And so that's the kind of stuff that people, these are important pieces of functionality that we offer. And another one is bitemporal data. A lot of MarkLogic semaphore users don't know this exists, but it's really important in some cases. And so what bitemporal means is that you can always go back in time and see what the database looked like at some point in the past. And the way that works is we don't actually delete the data. We just mark this data was valid from this point to this point. And so now when you query the database and you're not doing bitemporal, it just shows you the things that are current, where there is no endpoint for that. It became valid yesterday, and there is no marking that it ever ended up being valid. And then now but also you can go back and say, show me what the database where everything was valid on January 1st of this year. So we can do that. And we're really good at this because we're at some level schemaless in a document database, so that if you have a relational database and you delete a column from a table, you have to export the data and reload the data with that new schema. And so if you want to go back in time, if you're doing mortgages, which last 30 years, and you want to see what your database looked like 25 years ago, the schemas are totally different. You can't go to your current database and query it as it existed 25 years ago because it doesn't look the same. With us, every single record can be different than every other record. You can create SQL views that make them consistent, so you can query them as if they were all the same, but they don't have to be the same. So you can have your 25-year-old data with whatever fields were being used 25 years ago, your current data with whatever fields you're using today, and recreate the databases that existed in the past. So very few systems offer this kind of bitemporal situation. So if you're in a situation where you have regulators or you're getting sued because they're saying, oh, I made this payment on time, and you guys screwed up, and then you can go back and see, what did I know? Is this correct? And other systems don't have that kind of power that we have with the bitemporal data. And then another quick one is real-time alerting. So we have customers who put out millions of alerts a day. So these are news feeds. People subscribe and say, tell me every time the price of Microsoft drops by 10% in a 1-week period or something. And so people subscribe to alerts, and it's extremely efficient. We have specialized indexes that every time you insert, it basically does a query, but not against the whole table, just against that one record, and decides is the query true or not. And so we're able to determine if the conditions for the alert are met or not with almost no work. And so you can do millions of them, all one after another with no problem. And this becomes really important in things like fraud, that you're doing a payment system and you have 10,000 transactions an hour going through it. You don't want to look at each of them, but you have some criteria. This looks like it might be suspicious, so you define an alert, and then if it's suspicious, you get a message and your system can handle it. So you don't have to go through each one. And customer complaints, I used to make the joke, well, not customer complaints, but that you would define an alert that any time a trader lost more than a certain amount of money, it would automatically fire the trader, and you didn't need a human being involved. So that's the kind of thing that you could totally automate with this. And so this is something where if you have things where you need problems and you have lots of volume, you have lots of potential alerts you want, like the 6 million a day is people asking different questions about different stocks and things like that, then this is important functionality to be aware of. And then this is so I was discussing before about how we take all the different kinds of data, dump it into one place, and make it accessible. And the core technology for that is our Optic API. So this, in general, MarkLogic is 100% standards-based. We use our SQL as ANSI standard. We use our Sparkle is just standard, WC3 Sparkle. Our JSON, it runs off of the Google engine, our JavaScript. So in general, if you know the standard industry techniques, you know how to use MarkLogic. The one thing that we have to do ourselves is that if you want to combine your Sparkle query, your relational query, your document filtering, your free text searching, and your GPS stuff all in a single query, nobody does that but us. So we invented a new this Optic API so that you can have a single query that has all those things in it. You submit the query to us, and we will figure out how to handle each sub-piece for you. So it really simplifies and makes it possible to do all this. And also, with the Optic API, any query you put there, if the end results look like a grid, then you can just project it as a SQL table and make it accessible to Tableau or Python, anything else you might want to have access to that data, even though it's accessing all this kind of stuff. So let's move on to the use cases. So we're going to discuss 4. And as I said, all of these are things that we are actively working on now or recently. And so these are all things that many firms will need to do, and something that we have a lot of experience and a lot of ability. So I'm going to go quickly through these because of the interest of time. And so we'll start with GenAI. And so I'm not actually going to get into use cases for GenAI because the reality is that everybody's taking every use case and applying GenAI to it, and they're doing it with us too. But what I want to do is just talk about Progress GenAI. I don't know if you've been hearing about it for the last 2 days. I hope to have a slightly different take than they do and give you some other insights, especially on the path forward. So Progress GenAI is really focused on when you need the right answer. And this, again, the rest of the world is not there yet. The rest of the world is on the low-hanging fruit. So I've been going through the Microsoft training, and the very first thing they said is, okay, you want to send an invite to your colleagues for pizza. So that's what they're focused on. And they're focused on, or do you want to summarize? Every day they ask me, do you want me to summarize all your bosses from your email? They don't want me to ever read an email from my boss again. They want me to let GenAI think about what to think about whatever my boss has to say to me. So they're focused on the quick win. Come in, show them all these great things you can do really quick, get the money, and go on to the next guy. And so they want a 6-week sales cycle. And we can do that. I don't know that we offer any benefit, if that's all you're ever going to do. We are really focused on, you're a lawyer, you submit your brief, it's wrong, you get ridiculed by the judge, you get disbarred. You're a chemical company. We've had a lot of chemical companies here. You invent a new substance. You submit a report to the government. It's full of hallucinations and is making stuff up. You get a $1 billion fine, or things like that. So our focus is on when you need to get it right. So I spend a lot of time these days working with customers, and the industry standard is like 60% accuracy. And that's fine for making your pizza stuff. That's fine for if I ask ChatGPT to make this deck, 60% accuracy would be fine because I can edit it. But if you're a lawyer, if you're submitting government reports, if you're a doctor making diagnoses to your patients, 60% is not so great. And so our focus is on really getting it right, making it perfect. And the reality is you can't do that in 6 weeks. It's a hard problem. We make it easier. And we're going to discuss, you've been hearing about some of that why. We'll discuss the key points now. But that's why when you should focus on us and get going. And so the first part of that is security. So vector databases are the most common way to implement GenAI. Vector securities have no clue what. They work the same way the LLMs do. You feed it. They store stuff. They don't know where the data came from. They don't know who has access to it. And so are you willing to, if you've spent $2 billion doing research, are you going to feed that into an LLM so that when your competitors come and say, well, what did these guys do in research? They give detailed results of everything you've ever done, and $2 billion of your R&D is given to them as a free gift? Probably not. Are you willing to take all your patient records and put them in there? So if somebody comes in there and says, oh, how's this person doing? It gives a detailed list of all the surgeries they've had. Probably not. But are you willing to trust analysis without that data? If you've spent billions of dollars doing research, are you going to come in and ask questions and ignore all of the critical stuff you have? And the answer is no. And so you can't just rely on these off-the-shelf vector approaches. You have to build your own RAG solution, and that RAG solution can't just be a vector database. It has to understand security. It has to know who has access to what, so when different people ask the same question, they get different answers because they have different access rights. So if I ask about my medical history, I better get a different answer than if you ask about my medical history. That your answer better be a lot worse than the one I ask because, it's my medical history. So that's something, we started after 9/11. The government said we want to catch people before they get on the plane. We don't want to figure out who blew up the plane 2 weeks later, and they asked for firms to build new technology, and we were created because of that. And we had high security built in from the start. We never would have been allowed to get off the floor if we didn't have that. And many of our competitors started out as open source, where you want what's cool and what's easy, and you worry about security later on, and that doesn't work as well. And so that's the first part. And the second part is we're going to talk about ontologies. So we already discussed why they're so powerful. And then the question is, why doesn't everybody use them? And the reason people don't use them is because historically they've been hard to build and maintain. That you have to have ontologists who are highly skilled and who don't necessarily know anything about your business. And so, like I was at a big bank, I was pushing this ontology-driven approach. They said, yeah, we did that, worked really great. 6 months later, the ontology was out of date. We didn't have a clue what to do, so we shut it down, and we're not doing it again. And we have focused a huge amount of effort in the last 2 years to fix that problem. And we've had some discussion. So the idea is that users ask questions, and every time a user asks the question, we parse it and we figure out what the implied keywords are. And if that keyword does not exist in the existing vocabulary, we suggest it as a new term, and then a subject matter expert determines whether it should be included and where it goes. So there's no ontologist involved, and you do need a human, because if I've spent a lot of time working on these in the weeds, and 80%, 90% of the suggested terms are garbage. So if you just totally automated, your ontology will be full of noise, the results will be worthless. You need somebody in there saying, yes, this is a good term, but that doesn't need to be an ontology. So one big firm, a chemical firm, told me 2 years ago they had 40 ontologists. Now they have 2 half-time ones. Even though they love ontologies, believe in them, they weren't worth the cost. And they are we've been having endless meetings with them to go into how you build these systems, how you maintain them. And the beauty of this is that 2 years from now, your users will not be asking the same questions they're asking today. And this system will automatically evolve. Every time a customer types in a new query, we're tracking what terms they're interested in. So as the interests change, as new things happen, our vocabularies are evolving with the minimum possible work. And so we really have gone a long way towards solving the problem of building and maintaining these. So we have a lot of proof of concepts going on where we're testing this out. Our customers are building this and making it work and making it accessible to the users. And so this is another key differentiating technology. And so this is most important in the Gen AI part, but it actually works everywhere. That anybody anytime you think like that very first one with the bond, that wasn't a Gen AI question, but it would be easier for the bank if when users asked it, they saw, somebody was asking about munis, and then automatically those terms were put in there. And then the final slide is data quality. So when Gen AI first came out, it was just you feed it all your data, it does all the thinking, you ask a question, you get an answer, and it's magic, except that it's 60%. And then the RAG approach with the ontologies and everything else means you're getting a lot more data. And so you're actually giving it more appropriate data, but that doesn't end the problem. So suppose you have two documents. One says the sky is blue, one says the sky is red. You feed those into your system and you say, what color is the sky? And it's like, you know, one system will say red, one will say blue, and one will say, I don't know. And so what the answer to that is you rank your data sources. You say, this data source sucks. This data source is really good. And so when you ask the question, you only send them the ones that matter if they are a good source. And you only go to the bad sources if there's nothing from the good source and you just have to do it. And so this is something that the industry isn't thinking about at all. And we're not even pushing it because the easy way to go from 60 to 90 is with an ontology and really get the correct answer, you know, to feed it the data that's missing. But once you get to 90, it gets really hard to get to 98, 99, 100. And then you need to start thinking about things like that. And even another thing is that you want to feed the LLM. I've been doing a lot of work evaluating the answers of LLMs. And we're actually, MarkLogic Progress is better at identifying what piece of information is more important than the LLMs work the same way as vectors. It's just statistical similarity. So even if you feed it the right data, it's not, you know, when we try to go from 90 to 100, we sent it the right document and it didn't use it. And it was because you send it 1K blocks and you send it 10, 20 blocks. Now it has 20K of stuff to create a 500-word answer. It has to figure out which piece of text, and if its abilities to figure out what piece of text is appropriate are not as good as yours, it's not going to pick the right ones. So what you really need to do is not just send it the right data, but avoid sending it the garbage, avoid sending it the irrelevant stuff, avoid sending it the wrong stuff, and just make it, you know, a lot of the Gen AI world is all about, well, if we can just expand the number of tokens to 1 billion, then we can feed it everything and it'll magically figure out the right answer. But the correct result is everything you feed it, you're implying is good and valid and should be considered. And so that puts it on you to only send it the information that is good and valid. So you need to be putting a lot of work into not just making sure you get it the right data, but that you avoid sending it that doesn't matter, because the LLM's ability to figure out if a piece of information is important to this is not as good as ours is. We can do the vector approach, but we also have the ontology approach, and we have shown in a lot of cases that we're sending it the right stuff. We figured it out, and even after we send it, they're not getting the right answers. And then another, deduplication, mastering, that's another one. One quick thing I wanted to just bring up is another benefit of ontologies. So recently, like 2 weeks ago, OpenAI was sued because they did a depression application and people committed suicide, or at least one person did. And so they're being sued. And one thing, not necessarily that person because we don't know what happened, but experts went there, and so they would ask a question saying, I'm depressed, where's the tallest bridge? And the correct answer is, everything's okay, you're going to get better, call these phone numbers. And OpenAI says, well, it's over there. and any professional who did that would be disbarred and never work again. And this is an ontology problem, because the way they should have modeled it, they should have said, we have a category called self-harm. If they ask about guns, if they ask about tall buildings, that they're expressing a desire to commit self-harm. And if you do self-harm, you send a message of encouragements, you give them phone numbers. But on the other hand, if you're a sightseer looking for fun places to go and somebody says, where's a tall bridge, you give them the answer. And so they should have had an ontology that said, if this is a depression situation, then we have a category called self-harm, and it has these different kinds of self-harm. And if you're doing a travel agency thing where you're trying to find interesting things, then if they ask about tall bridges, you give it to them. So they could have, they shouldn't rely just on the ontology, obviously. They should test it and verify it. But if they had had a proper ontology that understood that asking about bridges can mean totally different things depending on the context, they would have avoided these problems. So that's another aspect of data quality, that the system doesn't understand what the the data means in that that's why we're always saying context is king and blah, blah, blah. We go on and on about it. But those are the kind of reasons why you really need that. And regulatory and compliance reporting is something where you got to get it right, you got to get it fast. And the key thing with MarkLogic is, the high-level summary is, in the past, the big banks, every time they got a new regulation, they would build another technology and data silo. And it's really expensive. You have to do it. If you don't do it, you get $1 billion fine. If you don't do it over and over again, you get shut down. But on the other hand, it costs a lot of money. It doesn't make you a nickel, and the firms hate doing it. And so our advantage here is we are a very flexible data platform. You build it once, and now you can use it for all of your things. It's not, a lot of banks literally, every time a new thing comes along, they create a new team and build a whole new thing, and they reuse very little of what they did. And so these are the kind of things that, so we're like subpoena response, where we have firms using us intensively for that, for payments transactions. And we have a lot of firms who are just building their generic data hub that stores everything, and then the system gets fed all the stuff that they need to do that. And so we don't even necessarily know the details, because this is just one more end user. They built their data hub, and then CBOS is one end user, and the EC, also the data protection is more privacy that we got into, and the theft and tax evasion is another one, consumer protection. And this is something that's growing, that it's not just compliance, but it's the actual fraud, that the amount of fraud being committed in the world is growing like crazy, and governments are absolutely not keeping up with it. They're not providing you the protections. And so more and more of the burden of protecting their customers is falling upon the individual banks and also the end users. And so having it, and we can't help the end users directly, but we can help the firms providing that. So these are the kind of things, this is what they're using us for. And so this is a common use case that we've been used for, is know your customer. Know your customer can mean a lot of different things. In some places it's, okay, I need to take pictures of your passports and driver's license and get your name and phone number. Other places it can be much more intensive than that. And so a lot of major firms, top three banks, top 10 investment banks have built systems on us. KPMG had one that they were selling a few years ago, built on top of us. And so we can handle all the different types of data you might need for a Know Your Customer application. And Know Your Customer is really a core for being anti-fraud and everything else, because there are specific laws, and there's a lot of, the banks are responsible for knowing that their customer, if their customers are committing fraud and they've been lax and just allowed it to happen, then they're in trouble too. So this is something that matters. Legal discovery is one that we've had a fair amount of. We have a partner who's actually in the room here, I think, who built an application on us, who after the derivatives crisis, everyone was suing all the banks, and you have to feed all the information. You get sued like crazy, and that's very expensive. You don't want to give them information that they don't have to give when they get sued and are doing discovery, but you have to give them everything, or if you get caught hiding stuff, you automatically lose in some cases. And so MarkLogic is really good. And the other thing about legal discovery is they can ask anything. They can say, I'm suing you because I think you discriminated against pig farmers in Iowa in the 90s, and I am really mad about it. And so you have to have information that would apply to that. They can ask any question they want. You need to be able to dig through potentially millions of records, quickly determine which ones you have to send them, which ones you don't have to send them. And so this is a really good use case for us. We have done it directly, and we have had partners who built applications. If anyone's interested, I'll point out exactly who it is, or he can raise his hand. But okay, so anyway, we have people who have been doing this, and it's a good use case for us. So the next one is XML-based standards. So most of the data spread around the world is relational or JSON, but most of the standards describing data are XML-based. And that's because XML is much richer. XML has things like namespaces and a lot of other stuff. And so the people who build these, I think the next slide actually shows, so these are a few. ISO 20022, which is payments. So the world used to not be that way, but in the last few years, it's switched to this XML-based. There were different standards, different trading platforms had different data modeling for it. Now, last February, the Federal Reserve was the last holdout. They switched over to ISO 20022. So now basically all the payments in the world are sent through XML-based information. And half of the payments in the United States are settled on a MarkLogic base. I mean, the settling is done by a mainframe system, but the data is stored in us for half of the payments sent inside the United States, and they're using it for things like subpoena response. So they're very good. And other industries, you have Accord, MISMO, FPML, and in healthcare, you have HL7, which is what I know it as. I guess it's called FHIR now. But so all of these standards are complex XML-based standards that we are the best approach. With other, the next slide may get into that. No. Oh, well, it does a little bit. But the key thing is if you're going to Mongo or something, you have to convert it. If you're doing it in relational, you have to parse it and use it. We're the only big player where you load the data into us. So that dashboard I showed at the beginning, a lot of that data was XML. You just store it straight. We're an ACID database. You have real-time access to it. We can create SQL views of that data in real time. As soon as you insert it, it's immediately accessible to you, and no one else does that. So if you're one of these vendors who's processing FPML data, ISO 20022 data, if you do mortgages and you have Accord data, then we are the quickest and easiest way. You can just dump the data into us. You can easily create a SQL view of that data, and your users can be running with it and accessing it very fast, like in a day, perhaps. I mean, it depends on what you want to do and how much effort, but you can just load 100,000 transactions in there and create your SQL view of it and be up and running faster by far than with anyone else. And so this is from the XML standard, and it's a lie. So the XML standard asserts that it will be easy to process it, and the XML standard gives you no guidance on how to do that. They just, it's empty words, and you really need something like MarkLogic to make that happen. And so I think this is the last one, workforce management. And so there's a couple of variants on this. That one is, so this has been a big moneymaker for us over the years, that very large firms, a lot of firms grow by acquisition. And so the problem is you buy a new firm and they have their own HR system. And sadly, if you work in HR, one of the things that happens when firms acquire other firms is they want to save money by streamlining their HR processes, which is kind of painful if they're all totally independent of each other, and you have to do all this work. And so we have, over the years, had a number of very large projects to help firms that sometimes they've acquired 50 or 100 firms, 50 or 100 different HR systems, and they don't want their users to have to go to 50 or 100 systems to find what they're looking for. They want just one, so they come to us, and this is something we're very good at. We have a lot of experience with. And so what we do is we bring the data hub approach for bringing in all the data, we harmonize it, we make it consistent, we make it accessible. And then a second one, which is actually gotten up in interest very recently, is talent acquisition. So there's two parts to this. One is you're a big bank, you have 5,000 positions. Every day, 5,000 people apply for jobs. And the people applying for the jobs may be applying for the wrong job. They may be applying for one, but they'd be a 10 times better fit for this one. And so the US government, I don't think I'm allowed to say which part, actually is doing this with us and has been for several years, that every time someone applies for a job, they look at all the openings and figure out, okay, what are the skills needed, and these other slides will cover that a little better. So they pull in all this kind of information and make profiles of the people. They make profiles of all the positions, like they need to live within 50 miles of this spot. They need to have these skills, blah, 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 and then pick them. And also, they're not limiting themselves to external new applicants. If a new position opens, then maybe there's an internal employee who would be a better fit than anyone applying for it. And so it does all of these things. And then the newest wrinkle on this is firms are starting to come to us, not necessarily for new hires, but just anytime they start up a new project. We have 40,000 employees, and so let's figure out, we want to do this new thing we've never done before, so let's figure out which of our employees are the best fit, who should be on that team. And so this is a simplified version of it, and it actually can be more powerful because you know a lot more about your existing employees than you do about, you don't just have their social media and their resume. You also, you have all your employees, rankings and stuff and everything else you've ever done. So this is something that we're starting to see an interest in with Gen AI. This is becoming a Gen AI thing, that they're using this sort of thing, that they're using our core abilities to do it, but then building the profiles and things you can potentially do faster if you say, okay, what skills do I need for this opening that I have, and things like that. So the whole system can be automated, made faster. You're still building it on the core. You might want to say, okay, who's published the most articles in this subject and things like that. And so that's our core ability, but then now figuring out, okay, what are the criteria we need for, we might do 5,000 projects in a year, and we don't want to have to sit there doing all this laborious work, so let's use Gen AI to help us build that out and make it happen. And so this is the last slide. I hope I'm not too far ahead of schedule, but this is the last session, so I'll let you go early if we are ahead. But so these are some of the functionality we talked about. These are the kind of things that the technologies you might want to use. So ISO 20022 is actually a stand-in for XML, because that's our, we are now, half of America's payments are being done through ISO 20022, so it tends to get elevated a little bit. But so these are the kind of technologies you need for each of these, and then that gives you an idea how hard would it be to do this with other technology. So if you need multi-model data, which is everybody, then we're a good fit almost by definition. But then we have all these other use cases, like the ability to classify the documents or do fact extraction, and alerting can be really important, the ability to look back in time. Most people don't care about it. It does have the drawback, it makes the database bigger because you're never deleting anything. But some cases, it's really mission critical and you absolutely need it. Universal repository is just the idea of a 360 view of the data. So there's a lot of cases where you really want to know everything about your users. In finance, you might want to have a bond we've had customers build bond 360s where they want to know everything about their bonds. It can be, some of the times the documents would be 20, 25 megabytes just to describe a single bond that they had issued, a loan they had issued, things like that. But so these are an idea of which pieces of capabilities that we offer and what different use cases need, so you can help you frame the problem. Think about it, that if you have a new problem, you should really give us a shot at it, and we do have more functionality. This is some of the core stuff that I pulled out. But so that's it. And if anybody has any questions or anything, I'd be happy to take them. And that's okay if you don't too. So. You've been dumped with data, and okay, thank you.
Thanks, David. This is the last